Hello everyone, my name is Pipin Abram. In today's video, we are going to talk about Coulomb's law. Now, before we start Coulomb's law, there is an important note that we must know. So let's get to it. Alright, so the note says, when two identical charged bodies are touched, the charges divide equally. That means, so the note is talking about identical body, right? Now, what do you mean by identical body? Identical body means we're talking about any two bodies which are similar in shape, which have this exact same shape, but they might be having different charges. It doesn't matter, right? But the note says if we have two identically charged bodies and they are touching, then transfer of charge takes place. Yes, we have learned in the previous video that by friction, by in contact, when two bodies are in contact, then transfer of charge takes place. Very similarly, so if identical charged bodies are touched, then the charges divide equally. That means, let's say I have this body A and this body B, two different bodies, and let's say these two bodies are identical in nature, right? Let's say it has Q1 charge and it has Q2 charge. All right, and in this second figure, both the bodies are touching. So according to our note, the charges must divide equally, right? So how will it go about it? Q1 plus Q2 by 2. Very similarly, Q2 plus Q1 by 2. So the charges will divide equally, right? We can take example. For example, let's say if Q1 was 10 Coulomb. Again, 10 Coulomb is a huge charge. I'm taking it for example's sake, right? So I have Q1 to be plus 10Q, Q2 to be minus 10C Coulomb, right? So when they are touching, the charges will divide equally, right? So this will be 10 plus minus of 10 Coulomb divided by 2, which will be 0, right? Very similarly here also, this will be minus 10 plus 10 Coulomb divided by 2. Answer will be 0. I hope that is understandable to you. So if that is clear, let's move to our main topic, that is Coulomb's law. Okay, few important things before we get to the Coulomb's law, before we get to the statement of Coulomb's law, right? The first thing is Coulomb's law talks about the force of interaction between any two charged bodies. It talks about the force of interaction between any two charged bodies, right? Second thing that you have to understand is that Coulomb's law is an experimental law. It was experimentally, proved. It was experimentally proved that the relation that we are going to talk about in the coming few minutes is experimental. It was experimentally proved, right? Okay, this law was named after French physicist Charles Augustin de Coulomb. So there were other people who also come up with this result, but he was the person who actually formulated it, and he made it into a thesis, right? That's why this law is after his name. All right, he was a French physicist. Okay, there are few conditions before we can apply Coulomb's law. So there are few conditions. If those conditions are fulfilled, then only we can apply Coulomb's law. So let's get to those conditions. First condition is the charges must be point-like. The charges must be point-like. Now, what does that mean? Now, we all know that whenever we talk about a body, let's say I have this body. This is body A. Let's say I have another body B. Let me call it body B, right? So obviously when we talk about charge, when we talk about electrons in the body, then the electrons in the body will be distributed in different places, right? It can be here, it can be outside, it can be on the surface, it can be inside. So there are different places where electrons can be redistributing, right? Very similarly, same case will be going with the body B. Electrons will be at different places, right? Now my question is, what do we mean by point-like, right? Okay, so in order to understand that, what do we mean by point-like, there are two terms that we must understand. Number one is separating distance, and second one is linear distance. Okay, separating distance is that distance. Okay, let me write it down. Separating distance, okay, from one center to another center, the distance between these two. This distance is what you call as separating distance, ST. Let me call it ST. Okay, I hope that is understandable. Then there is next term, that is linear distance. Sorry, this is not linear distance, this is linear size. Let me just erase this part. This is linear size, not linear distance. Linear size. Now what do we mean by linear size? Linear size is actually this size. This is what your linear size. I hope that is understandable. Linear size, let me call it LS. So what is linear size? Linear size is the diametrical distance for this particular figure. That is the linear size for that figure, right? Now we can call this charge to be point-like if it fulfill this condition. The condition is that the separating distance must be much larger than the linear size. If this condition is fulfilled, then I can say that my charges are point-like. I hope that's understood. So for example, I have two charges, and if they are separated by very large distance, if they are separated by very large distance, if I have two charges, right? So if these two charges are very close to each other, then I cannot say that charges are point-like. But at the same time, if they are very far away, this distance is so large as compared to this distance, the linear size, then I can say that these two are point-like. I hope that is understandable. Yes or no, right? This is the first condition that we must fulfill in order to do the Coulomb's law. Second condition is that both the charges must be at rest. The law is that only applicable when both or one of the charges at rest. Either both the charges must be at rest or one of the two should be at rest in order for the Coulomb's law to be applicable. If, let's say, if both the charges are moving, then you cannot apply Coulomb's law. Either of the one charges must be at rest or both the charges at rest, then only we can apply Coulomb's law. I hope that is understandable. The third is that it is a central force. Now what do we mean by central force? Central force means, let's say I have one charge from the center of this body to the center of the another body. So this A body, B body, so that the force of interaction will be along this particular line from one center to the another center. That is how. Now it is very understandable that when we said that both the bodies or both the charges must be point-like, right? So it makes it understandable that the force of interaction will be central in nature, because we're talking about point charges from one center to the another center. That is the line of force. I hope you guys can visualize. Yes or no, right? So these are the three conditions. If these three conditions are followed, then we can apply Coulomb's law, right? Okay, so let's get to it. What is Coulomb's law? According to the statement, Coulomb's law states that the force of interaction, like I said, between any 2 point charges, between these 2 point charges, is found to be directly proportional to the product of the magnitude of both the charges and inversely proportional to the square of the distance between them. So let me just draw that out so that you guys can understand. Okay, so I have one body here, A, from this center to another center. This is my body B, right? So it's a central force, so I hope you guys can follow this, right? The distance between these two, let me call it R. Okay, all right. This body A has some charge Q1, body B has some charge Q2, right? Now let's read the statement. Coulomb's law states that the force of interaction between any 2 point charges, so let's assume that these two are point charges, right? That means your linear size is very less as compared to your separating distance. Let's say this thing is followed, right? Okay, great. Now If that is followed, the two charges is found to be directly proportional. The force of interaction. So first thing is the force of interaction, that is your F. The force of interaction between these two point charges is directly proportional to the product of the magnitude of both the charges, right? So first charge has magnitude q1, second charge has magnitude q2. So that is, it is directly proportional to the product of the magnitude of both the charges. So first thing we have written. Second, and inversely proportional to the square of the distance between them. Distance between them is r, so it is inversely proportional to the square of the distance between them. I hope you guys can follow, right? So we all know whenever we take out the proportionality, there is always a constant which comes in, right? So when I take out the proportionality, I will get force will be equal to some constant which I am writing it to be k multiplied by q1 q2 upon r square. This is the magnitude of the force which they are going to experience, with both the point charges are going to experience. I hope this is understandable, yes or no? Okay, so interaction which we just written was F is equals to k q1 q2 upon r square, right? Now we have to understand here, this k, the constant of proportionality, it is very special. Why it is special? Because this constant depends upon the medium in which it is in. For example, in air, the value of k will be different as compared to it is in oil or in water, right? So in different mediums, the values of k will be different. Now, this k has a specific value that is equals to 9 into 10 to the power 9. And we can find out the unit, that is Newton meter square per Coulomb square. The value of k is this when we are talking about vacuum. When both the charges are in vacuum, the value of k will be 9 into 10 to the power 9 Newton meter square per Coulomb square. I hope that is understandable, right? Okay, now k can also be written as 1 upon 4 pi epsilon. Now this epsilon, this is a Greek word which which looks like a e, but you will call it epsilon. It's a Greek word, right? Now this is what you call as permittivity of medium. It is the permittivity of medium, right? Okay, the k can be written as 1 upon 4 pi epsilon naught. Epsilon naught is used when we are talking about vacuum. This is something which is important. Epsilon naught is used when we are talking about vacuum, and you will call it permittivity of free space when we talk about vacuum, right? So when we are talking about permittivity of free space, at that time the value of epsilon has a constant value which is equals to 8.85 into 10 to the power minus 12, and the units are Coulomb square per Newton per meter square. I hope you guys are following, right? So very similarly, so when you write k is equals to 1 upon 4 pi has a value that is 3.14 into 8.85 into 10 to the power minus 12. There the value comes out to be approximately 9 into 10 to the power 9, that is Newton meter square per Coulomb square. So I hope these things making sense to you, right? So some values which you guys have to by heart, the value of k, because we're going to use it a lot. The value of epsilon naught, that is 8.85 into 10 to the power minus 12 Coulomb square per Newton meter square, right? Permittivity of medium, that is epsilon. Permittivity of free space, so whenever we talk about permittivity of, so most of the problems we will be talking about free space, so I will be using this term a lot. that is k is equals to 1 upon 4 pi epsilon naught. So most of our problems will be using that, but in some problems I'll be using this also, that is 1 upon 4 pi epsilon. So you guys must be knowing what is epsilon. Epsilon, we're talking about any particular medium. Epsilon naught is for vacuum, right? I hope that is understandable to you, right? So now, very important thing, vector form of Coulomb's law. So before I go into this topic, we have to understand that force is a vector quantity, and just now we have discussed that F is written as K Q1 Q2 upon R square, or I can write my force as 1 upon 4 pi epsilon naught when I am talking about vacuum, Q1 Q2 upon R square, right? So this is something which we talk. So let me call it in vacuum. So we are in vacuum, right? So in vacuum I can write this, yes or no. Now remember, this is only magnitude, and we all know that force is a vector quantity, so it must have a direction. Now you must be wondering, sir, from where does this direction come from? Okay, let me make you guys understand that. Okay, let's say I have a body A here, I have a body B here, right? I hope you guys are following, right? So from the center to the center, this was the separation, or I should say the force that is going to act, right? Now again, we know there are two types of charges. One is positive, another one is negative, right? For time being, let's say this A has Q1, that is positive charge. B also has Q2, that is again positive in nature. So we all know when we have positive, these two are going to experience a repulsion, right? These two are going to experience a repulsion, right? So how you will tell, how will you talk about this repulsion? You will see the body B is going to experience a force of repulsion because of body A, yes or no? So we will write, and which will be having the direction over this one, yes or no, right? So we will write force on B due to A will be in that direction. Very similarly, body A will experience a force in this direction because of body B. So you will write force on body A because of body B. So you guys can actually see the direction of the force, yes or no? You guys can see the direction of the force, right? Okay, great. So now we are supposed to find out the vector form, right? So in order to go into detail, let me just make you guys understand. So whenever we talk about vector has, let's say, a magnitude. Let me say a magnitude, F magnitude, multiplied by the unit vector, yes or no? Unit vector, or I should say F cap, the direction along which the magnitude is going, yes or no, right? This is how we write it, yes or no? I hope that is understandable to everyone, right? Okay, great. So if that is clear, let me just draw a origin. Let's say this is my origin, 0 comma 0, right? Okay, so from this origin to my first position, let me call this as my r1 vector, position vector, right? From this origin to my second charge, let me call it r2 vector, second position vector, right? And let's say I'm supposed to find out FBA vector. FBA vector is along that direction, right? It is going along that direction. So I'll just draw my third vector along that direction. I hope you guys can follow this, yes or no? So this is, let me call this as my R vector. Now according to triangle law, which we have studied now 11th standard, so you guys can see R1 plus R2 will give me a resultant of R2 vector, yes or no? So I can simply write clearly, just listen very closely. So R1 vector plus R vector will be equal to R2 vector according to triangle law of vector addition, yes or no? I hope I'm making sense. Great. So if this is true, if this is true, I can write my r vector, that is the separation between A and B, to be r2 vector minus r1 vector. Yes or no? Very important. I hope that is understandable to you. Yes or no? Right? Great. So if somebody asks me what is my FBA vector, so we all know the magnitude, that is K Q1 Q2 upon, okay, R vector. Now here this is the magnitude we are talking about, right? So you just tell me, can I write it like this? R vector magnitude, the magnitude of r vector, yes or no? That is the distance, right, multiplied by, now this particular part was the magnitude. Now I have to multiply it with the unit vector. Now here you guys can see r vector can also be written as r2 minus r1. Yes or no? R vector can also be written as r2 minus r1, or you guys can write it like this, r cap. Yes or no? Right? So here you can write FBA vector to be K Q1 Q2 upon r vector magnitude multiplied by, okay, now we know whenever we talk about a cap, that means a vector upon a vector magnitude, right? So very similarly, r cap will be equal to r vector upon r vector magnitude. Yes or no? Right? Okay, here we forgot there was a square sign. Yes or no? Very similarly, here was also a square sign, right? So this can be further written as FBA vector can be written as K Q1 Q2 upon, yes, this was r vector whole square multiplied by r vector upon r vector magnitude, or you can write it FBA is equals to K Q1 Q2 upon r vector magnitude whole cube multiplied by r vector. Yes or no? This is the vector form of Coulomb's law, or you can write it in another form, because you guys just saw that you can write your r vector as r2 minus r1 also. So instead of r vector, you can replace your r vector as r2 minus r1, right? So again, r vector can be replaced as r2 minus r1 vector. We have just seen here, right? I hope that is making sense. So I can write my FBA vector also as K Q1 Q2 upon r vector. Instead of r vector, I can write r2 vector minus r1 vector mod whole cube r2 vector minus r1 vector. Yes or no? I hope this is making sense, right? Yes or no? Very similarly, if somebody, now this was your FBA vector. Now if somebody would have asked what is FAB vector, how you would have done that? Now FAB vector is in opposite direction, that you have to understand. So FBA vector was in this direction, so FAB vector will be in the opposite direction, and accordingly your, instead of the r will become, so in the first one r was r2 minus r1, but in this one it will become r1 minus r2. Yes or no? That is the only difference. And here this will be changed, like FAB will be equal to K Q1 Q2 upon, instead of r2 minus r1, it will be r1 minus r2 whole cube r1 minus r2. I hope that is understandable. Take your time to understand it. There is no rush. Take your time to understand it. If you have any doubt, you can comment down in the comment section. That's all for today. I hope you understood it. Just just go through it again and again so that you can understand it, right? That's all for today. I hope all of you are doing good. Stay home, stay safe.